Case study, leveraging AI in proactive threat hunting, a game-changing approach to cybersecurity at Novatech Inc. Cybersecurity at Novatech Inc. was a high-stakes game, and the stakes had just been raised. Over the last year, the company had experienced multiple attempted breaches, each more sophisticated than the last. It became clear that traditional security measures were no longer sufficient. This realization led the Chief Information Security Officer, Dr. Sarah Mitchell, to explore the potential of AI-driven tools for proactive threat hunting. Dr. Mitchell convened her team of cybersecurity professionals for a strategic planning session. "We need to stay ahead of these threats," she said, pointing to a series of charts displaying recent intrusion attempts. "Our current systems are reactive, not proactive. It's time we leverage artificial intelligence to enhance our threat detection capabilities." The team began by examining the capabilities of AI in processing and analyzing vast amounts of data. Unlike human analysts, AI could sift through terabytes of network traffic data, logs, and other indicators in real time. This ability was crucial for identifying anomalies and patterns that might indicate a novel threat. The first question her team faced was, how can AI tools improve our current threat detection processes? AI tools, as the team discovered, are not bound by static signatures that only recognize known threats. Instead, they utilize machine learning algorithms to detect anomalies in network traffic and user behavior that could indicate an emerging threat. One of the team members, John, an experienced threat analyst, pointed out, "With AI, we can identify unusual patterns that would go unnoticed with our traditional methods. For instance, unseen attack vectors causing unusual data flows can be detected and analyzed swiftly." Taking a step further, the team explored the role of machine learning in proactive threat hunting. They discussed supervised and unsupervised learning algorithms. Supervised learning, they learned, relies on labeled datasets containing examples of both benign and malicious activities. This allows the algorithms to classify new data accurately. Meanwhile, unsupervised learning identifies patterns and clusters within the data without needing labeled input. The second question arose, which type of machine learning algorithm would be most effective for our needs, supervised or unsupervised learning? Jane, another team member, proposed using supervised learning for its precision in classifying known threats, but stressed the importance of unsupervised learning for its potential to uncover previously unknown threats. She supported her argument with examples of clustering algorithms, grouping similar network behaviors, flagging anomalies that warrant further investigation. One of the most compelling advantages of AI tools in threat hunting is their ability to adapt continuously. Unlike static systems, AI algorithms evolve by learning from new data. This capability was particularly appealing to Dr. Mitchell, considering the ever-changing landscape of cyber threats. The next question posed to the team was, how can we ensure that our AI models remain relevant and effective over time? Dr. Mitchell emphasized the necessity of continuous learning. "Our AI models must be dynamic," she said. "They must evolve with the threats." The team resolved to integrate adaptive learning processes, ensuring that models are updated regularly with new data to maintain their effectiveness. This dynamic approach would enable their systems to stay one step ahead of attackers constantly. Another intriguing application of AI the team discussed was natural language processing. NLP allows AI systems to analyze and interpret human language, which is critical for processing unstructured data like threat intelligence reports and social media posts. The fourth question asked was, how can NLP be integrated into our threat hunting processes to enhance our insights into potential threats? Tom, a specialist in data analytics, highlighted the potential of NLP in extracting relevant information from vast amounts of text data. By using NLP, we can sift through threat reports and online forums to identify mentions of new vulnerabilities or exploits, he explained. This capability would allow Novatech to take preemptive measures against emerging threats, further fortifying their defenses. Predictive analytics also emerged as a powerful tool in the team's arsenal. By analyzing historical attack data and current trends, predictive models could forecast potential threats, enabling Novatech to act before an incident occurred. The fifth question emerged: what specific types of predictive models would be most beneficial for forecasting potential threats, and how can they be implemented? The team decided that time series analysis and anomaly detection models were critical for forecasting. By examining historical data, these models could identify patterns and trends that precede attacks. Dr. Mitchell suggested creating a dedicated team to focus on developing and fine-tuning these predictive models, ensuring they provide actionable intelligence that the security team could use to fortify defenses proactively. However, the deployment of AI in threat hunting was not without its challenges. One significant concern was the quality and representativeness of the data used to train the AI models. Biased or incomplete data could lead to inaccurate predictions, potentially overlooking critical threats. The sixth question was, how can we ensure the quality and representativeness of the data used to train our AI models? The team acknowledged that diverse and comprehensive datasets were essential for training effective AI models. John suggested collaborating with other organizations and using open-source threat intelligence feeds to enrich their data. By incorporating a wide range of data sources, Novatech could ensure their models were trained on a representative spectrum of potential threats, reducing the risk of bias. Finally, the team tackled the issue of interpretability. Security analysts must understand and trust the decisions made by AI systems, which can be challenging given the complexity of some machine learning algorithms. The seventh question was, what steps can we take to improve the interpretability of our AI models, ensuring that security analysts can trust and act on their findings? Dr. Mitchell proposed implementing explainable AI techniques, which provide insights into how AI systems arrive at their decisions. This transparency would empower security analysts to understand the rationale behind AI-generated alerts, facilitating informed decision-making. By incorporating visualizations and clear explanations, Novatech could bridge the gap between complex AI models and human analysts, fostering trust and collaboration. With these questions addressed and a strategic plan in place, Novatech began integrating AI-driven tools into their threat hunting processes. They adopted IBM's Watson for cybersecurity, which leveraged cognitive computing to analyze vast amounts of unstructured data, and Darktrace's AI platform, which used machine learning to detect and respond to threats in real time. As the implementation progressed, the team witnessed significant improvements in their threat detection and response capabilities. AI-driven tools identified anomalies and patterns that traditional systems had missed, providing actionable insights that allowed Novatech to thwart potential breaches before they could cause harm. In conclusion, the integration of AI tools for proactive threat hunting at Novatech Inc. marked a significant advancement in their cybersecurity strategy. By leveraging machine learning, natural language processing, and predictive analytics, the company enhanced its ability to identify and mitigate threats more effectively than ever before. The continuous learning and adaptability of AI systems ensured their relevance in the face of evolving cyber threats. While challenges such as data quality and model interpretability required careful consideration, the overall impact of AI on Novatech's threat hunting capabilities was overwhelmingly positive. As cyber threats continued to grow in sophistication and scale, the integration of AI in threat hunting proved critical to maintaining robust cybersecurity defenses.